Good afternoon, colleagues. Welcome to Engineer A. Today we are going to be looking at dimensional analysis. So let's look at a quick definition for dimensional analysis. So dimensional analysis are powers to which fundamental quantities such as mass, length, and time are raised to express a physical quantity. So the importance of dimensional analysis are as follows. It checks correctness of an equation. It helps derive formulas. It helps convert units. And lastly, it reveals the relationship between given quantities. So dimensional analysis, in a simpler term or a simpler explanation, just think of them as blueprints of a quantity showing what it's built from, even before you attach units to it. So the quantities that we measure in physics are as follows. The first one, we have mass, whose units is kg and are represented by the dimensional representation of capital letter M. We also have length, whose units is m, which is meters, and are represented by the dimensional representation of L. And lastly, we also have time, whose units is seconds and are represented by the dimension capital letter T. In some physics books, we also have constant, but in some physics books, it is said that a constant does not possess any dimension. But in some other physics books, you are going to find that a constant, which is represented by K, has a dimension of 1. So the two different concepts, at the end of the day, they arrive at the same deduction, meaning that even though a constant has 1, or you get rid of the dimension of a constant 1, or you just get rid of it, at the end of the day during computation, you are going to arrive at the same answer. So let's have some examples involving these same quantities. So we are going to before I forget, yes, the most important thing in dimensional analysis, you have to know the formulas for a given quantity and their derived units. It's very important for you to perform. If you want to perform dimensional analysis, you have to know these two. So let's have examples. So our example 1, write the dimension of the following quantities. The following quantities. So our first quantity we are going to be looking at is volume. And we know the formula for volume is length times breadth times height. We also know that the units for length is meters, multiplied by the units for breadth is also meters, multiplied by the units for height is, the units for height is also represented by meters. So we continue by replacing these units by their dimensional representation, and we all know that the dimensional representation for meters, it's